You buy a beautiful plant. The leaves are vibrant, you place it in the perfect patch of sunlight, and you water it regularly. You are doing everything correctly, yet the plant still starts to die. When this happens, our first instinct is to check the topsoil. We press a finger into the dirt to see if it feels too dry or too wet, and we adjust our watering schedule based entirely on that single touch. But often, the soil feels completely fine. It looks rich and dark. Meanwhile, the leaves of the plant continue turning yellow, drying into a crisp brown and dropping off the stem entirely. This happens because the plant is not struggling from a lack of sunlight or an improper watering schedule. There is a crisis happening entirely below the soil line. Judging a plant's health by looking at the dirt on the surface creates an optical illusion. That top layer hides a collapsing ecosystem underneath. To see what is actually killing the plant, we have to cross the soil line and look at the biological reality operating underneath the dirt. Down here, a specific biological requirement goes largely ignored. Roots must actively breathe oxygen to survive. When dirt stays constantly wet, heavy moisture eliminates the microscopic air pockets between the soil particles, cutting off the plant's oxygen supply. Trapped in this stagnant environment, the root system suffocates. The tissue begins to decay, resulting in a condition known as root rot. Up on the surface, a panicked owner sees the leaves of their plant drooping. They instinctively assume the plant is thirsty, so they reach for the watering can and pour more in. The very act of trying to save the plant accelerates its suffocation, sealing its fate under another layer of water. Suffocation is a severe threat, but the physical composition of the soil itself also degrades significantly over an extended period. Fresh potting soil operates as a living microbial ecosystem. Microorganisms systematically break down raw nutrients in the dirt, making them digestible for the plant. Over months of sitting indoors in a plastic pot, this ecosystem collapses. The dirt turns into a lifeless medium, zombie dirt. It still holds the plant upright, but it is devoid of beneficial microbes, leaving the plant to starve. While the biology fails, the physical environment breaks down. Over months of pouring water from the top down, it slowly compresses the soil into a dense, heavy block. This compaction creates a physical prison. The roots hit dense walls of packed dirt and cannot naturally expand to seek out any remaining nutrients. This cross-section demonstrates the channeling effect. Water poured over compacted soil cannot absorb evenly, forcing its way down through narrow paths of least resistance. Roots caught in the water channel actively drown, while roots on the dehydrated side splinter apart from thirst. The plant is fighting two opposite, deadly environments at the exact same time. Without direct intervention, recovery is impossible. Keeping a plant alive requires a shift in how we approach the pot. Rather than focusing on what we actively pour in, we must manage the overall environment, allowing for air, space, and balance. The first step is to stop relying on the look of the dirt. Instead, read the actual distress signals of the plant, paying close attention to drooping stems or yellowing leaves. Next, correct the mechanical environment. Ensure the pot has absolute drainage, so excess water can immediately escape, and gently loosen the top layer of dirt to reintroduce essential airflow down to the roots. Finally, address the biology. Occasionally repotting a plant replaces the exhausted physical medium and restores the missing microbial ecosystem. Understanding these hidden underground mechanics moves plant ownership away from reacting to symptoms and toward preventing them. Once we recognize that the life of a plant happens in the space beneath the surface, we can finally stop killing them by accident and allow them to thrive.